I am Ertekin. I work as a research scientist at MIT Sloan in Operations Research and Statistics Group at the Prediction Analysis Lab. One of the projects that I am working on is about electrical grid reliability. Electrical grid reliability will be a key issue as demand for electrical power continues to increase. Grids will need to accommodate a growing population and more high-tech appliances. Considering the future of a smart grid, it is tempting to picture completely remade grids of shiny new copper wires, each monitored by smart sensors. But unfortunately, this is very unlikely to happen because existing electrical infrastructure is huge. New York City alone has more than 94,000 miles of underground cable, enough to wrap around the Earth 3.5 times. So there is simply too much cable to replace or individually monitor. As data scientists, the questions that we are trying to address is, are there ways we can make an energy grid smarter to make it more reliable and safer without using sensors or replacing the whole grid by a new one? Actually, we show that historical data of the past failures and repairs can be used to predict serious events in the grid to prevent future failures. There are manholes on the streets, which are the access points to the underground cable system. Particularly, we want to predict serious manhole events, such as fires, explosions, or power failures. And alone in Manhattan, there are more than 53,000 of manholes. We use historical data of each manhole, which is stored for decades and which was extremely raw and noisy before processing. We propose a new statistical model, which we call reactive point processes. The RPP model has self-exciting, self-regulating, and saturating components. The self-excitement occurs as a result of a past event, which causes a temporary rise in vulnerability of a manhole to future events. And the effect of a past event fades gradually over time. And the self-regulation occurs as a result of an external inspection, repairs to the manhole, which temporarily lowers vulnerability to future events. And RPPs can saturate when too many events or inspections occur close together, which ensures that the probability of an event stays within a realistic range. We show for the first time that manhole events can be predicted in the short term, which was previously thought not to be possible. So this helps make the grid smarter, safer, and more reliable.